This is the second video for the introduction for Lab 2, and we're on this part right here. You want to describe how the encoder works and what the angular resolution is, and assume that in this question right here that you're using quadrature for that Vex shaft encoder. So the next thing is you want to generate this graph of motor speed versus motor voltage, and don't forget that the gearbox is 17:1. So, and you also want to, you can use Excel or MATLAB to do a linear squared fit to the data points and show the slope and the vertical axis intercept and comment on how well, how good of a linear approximation it is. And then you want to determine the speed constant, which is basically the slope of that curve, right? It will be in units of, you want that in units of RPMs per volt. In this next step of this lab, we're going to, you're going to build this current sensor. So the way this works is if you assume that you need a maximum current of 2 amps through the motor here, and you use a 0.5 ohm resistor right here, well, you can easily figure out what the maximum voltage is then at 2 amps from ground to this point right here. And you want to keep this resistor low because you don't want a big voltage change. You don't want to, you want to use that voltage change of 12 volts, as much of it as possible, to drive the motor. So with this current sensor, then you'll have a very low voltage here and you'll want to amplify it. So you can use a non-inverting op amp to do that. And if you'd like to get, if you have a, you can figure out what the maximum voltage is on this side. And if you know what that over here, say you'd want to get that up to maybe a maximum of 5 volts, then you can figure out what the gain is and then determine the values for R2 and R1. So that would allow you then to have a larger voltage here to measure to then determine, if you take the voltage you have over here and divide by the gain, you can determine the voltage over here, and then of course just using Ohm's law you can then determine how much current you have going to the motor. So the other thing we're going to do here is set up a low pass filter. So the idea here is that if there's some high frequency noise, we're just interested in that steady state DC voltage, and we'd like to filter out any noise. So I'd recommend that you watch this filter. I think this video, I think this is a pretty good video on low pass filters, RC filters, and let's see, however, you can see that it's 5T5 underscore KGDI. That's KGDI, right? So anyways, it's a pretty good video, and I'd recommend that you watch it. Now, one of the things you're going to need to do is determine the resistor. Let me just go back. Right, so you have to determine what the resistor value should be here, and to get a certain cutoff frequency. So let's talk just a bit about cutoff frequency. So here's the RC circuit, and this would be for a bandpass filter. So this has a low-end cutoff frequency and a high-end cutoff frequency. So the cutoff frequency is, in other words, you want only signals with frequencies in this range, in this particular bandwidth. So we're going to have a low bandwidth filter, so that we'll want to cut off any high frequency noise. And to do that, we use this equation right here. Right, I'll go back to here. And so in other words, here's the cutoff frequency. We know what we want that to be, and we know what size capacitor we have. Then we can just use this equation to go ahead and calculate the resistor to use for this RC circuit. And I'm going to stop here and pick up with the next video.